So today we're going to be doing 10.4, which is going to be trigonometric functions of general angles. So what's a general angle? Let theta be any angle in standard position with point P of xy located on the terminal side of theta and r distance from P to the origin. We define. So basically how this works is we have our angle theta, which we've been learning about finding. We start on our terminal side, our initial side, and we go to our terminal side. We're just opening up that angle, right? And that terminal side lands, and that creates the hypotenuse for a triangle, okay? And this is what we call theta prime, okay? Theta prime is the angle that's formed inside the triangle. Theta is the angle that created that line that got to the triangle. Okay, that's the difference between theta and theta prime. So let's talk about where x and y come from. So x and y come from the coordinate, and x determines your horizontal distance, length of the triangle. Y determines the vertical distance or height of the triangle, okay? With that being said, we have our 6 trig functions. We have sine being opposite, which is y, over hypotenuse, which is r. We have cosine, which is adjacent over hypotenuse, x over r. And then we have tangent, which is opposite over adjacent, y over x. Now with tangent, x cannot be 0, okay? Anybody know why x couldn't be 0 here? It would make it, when 0 is in the denominator, it makes it what? Undefined. So all of these last 4 have a consequence of being undefined if y or x is 0, which does happen. A coordinate can have x or y being 0, right? Cosecant is the reciprocal of sine. Cosine is the reciprocal, or the secant is the reciprocal of cosine, and tangent is the reciprocal of cotan, meaning we just flip that fraction. Trig functions tangent and secant are undefined when x is 0, and trig functions cotan and cosecant are undefined when y is equal to 0. So you don't have to memorize this fact. You can just kind of see it visually every time. You'll see that 0 ending up in the denominator, but this does follow true every single time, okay? So use it as a reference, but like I said, you don't need to memorize this as long as you understand the concepts behind it. So let's go ahead and try our first example. Given each point resides on the terminal side of theta, find the exact value of each trig function, and then state the measure of the standard angle and the reference angle. Remember how I said the reference angle has a little prime next to it, okay? That's going to be the angle inside the triangle, the one with the prime. So first thing we do is we plot this point in a general location as close as we can get it. So 1, 2, and then 1, 2, 3. So does everybody understand why my point ended up in the 4th quadrant? Because
-3.
Yes, +2, -3, over 2, down 3.
Oh, I see.
You see it? Yeah, there's no like boxes, so it's a little confusing, but you're just kind of like estimating it.
Yeah.
So then from here, what you always do is you connect your origin to your point, and that will always be the hypotenuse of your triangle, okay? And the hypotenuse will always be denoted by the letter r. Now, with this hypotenuse, there's 2 possible triangles you could form. You could form one over here or over here, but we remember the bow tie theorem. We always want to make it have that shape of a bow tie. So we want to go out this way.
So you always want to make sure it has that kind of like
bow tie shape.
Second, 4th quadrant bow tie looking.
Exactly. That's how you can tell which way your triangle should go.
Okay.
Okay. So from here, we're going to label what we know. We know that the x distance is 2, and we know that the y distance is -3. Yes, we know that distance cannot technically be negative, but this is more of a notation telling us the direction of the distance. The negative indicates we're going down instead of up. Now, with this information, we can now find r by doing what? Pythagorean theorem, right? So 2 squared plus -3 squared is equal to r squared. This comes out to be 13 is equal to r squared, which means that r is equal to square root of 13. Now, this angle inside, we typically have been calling this theta, but technically it's called theta prime, okay? And the reason it's theta prime is because this angle came from, we drew a larger angle, and this is like a piece of it, that was formed as a reference angle. There's a difference between a reference angle and a terminal angle. So theta is actually the angle if we started on our initial side, always here, we went out and opened up. This angle formed is actually what we call theta. This is theta prime. Okay, that's the difference between theta and theta prime.
So the angle all around is theta?
The angle that took you to get to, basically, you start on this x-axis every time. You open that angle up to r. Okay, you're creating r. That's the angle you use to form it. Theta is the angle we use as a reference to make the triangle. That's the difference between our angle and a reference. So now we're going to move on to labeling our trig functions. So sine is opposite over hypotenuse, which is radical 13. And cosecant is just the reciprocal of that. We just flip it. We bring our negative sign to the top. Cosine is adjacent.
Can you not have a...
Oh, I was just going to go back and do them at the end. We're just going to go rationalize at the end, but good catch, guys, good catch. And then secant is the reciprocal of that. And then tangent is opposite over adjacent. Cotan is adjacent over opposite. Now, if you have a negative in the fraction, you just bring it up to the top. Now, like you two mentioned, we do need to rationalize this because there's a radical in the denominator, which gives me negative 3 radical 13 over 13. And this one just gives me 2 radical 13 over 13. So I just did the rationalization process. Excuse me. Now, the way that we always find theta prime, okay, theta prime being the angle inside the triangle, is we pick the trig function that came out to be positive, which is which one? Cosine. We don't care about secant, there's no button on the calculator for that. So we care about the one that has a calculator button, we pick the positive one. Now, if that number has been rationalized, I will typically work with the original, not the rationalized version. It's easier. So cosine of theta is equal to 2 over radical 13. So if you ever want to find the angle measure, you use the inverse. Does everybody remember how to use the inverse? You flip, you flip the theta, the second button. So the way you're going to do that in the calculator is going to be 2 divided by 13 square root equals second cosine. And when you do that math, you should get 56.3 degrees.
So 2 divided by what?
13 square root button equals second cosine. Did you get it?
And second cosine?
Yep. You got an error? Alright, let's pause and look at it for a second. Now that we found our reference angle, now we're going to find theta itself. So theta itself is going to be different every time, so you have to be careful about finding theta itself. You have to be a little bit intuitive here. You have to kind of use your intuition. You can't really, there's no like set way I can tell you how to do this. So the way that we find theta is we look at how that angle could have been formed. So that angle we always start on the x-axis on the right here. And we opened up to form that angle. Now that angle almost makes a 360, right? But it doesn't quite make a 360 because it has this piece here. So any ideas on how I could find the measure of that angle? Good. 360 minus the 56.3 piece, which will come out to be 303.7 degrees. 303.7. So is everybody good with how we got that? And like I said, it's more of an intuitive thing to find it every time. So now we're going to move on to the next one. We're going to plot our point. So -1 is over here, -5 is way down here. We end up with a point here. Now, with that point here, I'm going to kind of bump it out here a little bit. I know that that's not as accurate, but the reasoning is otherwise you won't be able to see my triangle. So yes, I know this is a -1. It's just for the sake of you seeing my work, I'm just kind of making it a little bit exaggerated, okay?
So should we put it in the normal spot then?
You can if you can put it in the normal spot, that's fine. But if it's only for reference, so if you want to ever make it like a little bit bigger to see the triangle, that's totally fine as long as you're in the right quadrant and you label everything correctly. It's just sometimes that when it's tiny, it's like hard to see that and draw on it and stuff.
Yeah.
So we draw in our triangle, and it always should have that bow tie shape. This
Yeah, it's kind of hard to draw that triangle.
with the -1, yeah. That's why I just make it bigger, but we just label everything okay.
Would you take
No.
points off?
Definitely not. I won't care about that as long as it's in the right quadrant.
Okay.
Yep, as long as it's in the right quadrant and you label everything okay. This is theta, okay?
I thought that was theta prime.
Yeah, theta prime. I wrote it as theta prime, I forgot to say that. So that's theta prime. This is -1 because that's your horizontal distance, and then this is -5, which is your vertical distance. So is everybody good with that? Now how could we find our r, which is the hypotenuse?
And r is always going to be the sign for hypotenuse?
Correct. In this particular application, yes. So that's going to be -1 squared plus -5 squared is equal to r squared. That's 26 is equal to r squared, which means r is equal to the square root of 26, which unfortunately does not reduce. Okay, so it's just square root of 26. Now that we have that, we're going to do our trig functions. Sine is opposite over hypotenuse. And I'm going to rationalize at the end. Cosecant is negative radical 26 over 5. Cosine is -1 over radical 26. And secant would be the reciprocal of that, which would be negative radical 26 over 1, which is just negative radical 26. Bless you.
Thank you.
Tangent is opposite over adjacent, which ends up being -5 divided by -1, which is just 5. And cotangent would be -1 over -5, which is just 1/5. So tangent and cotangent will become positive here, which makes sense because it is the third quadrant, which is the rule of the third quadrant. Cotangent and tangent are positive in this quadrant. Now that we've done all that, we're going to go back and rationalize what had not been rationalized. So I just rationalized, okay? That's all. So I end up with these values. So now we are going to find our theta prime. So the way we find theta prime is we pick the trig function that is positive, which is which one here? Tan. And you're going to use the inverse function to find its angle. So you're going to do 5 inverse tangent, okay? So basically you're doing tan inverse of 5, which should give you theta prime. So 5 second tan, that should give you 78.7 degrees.
So to get theta prime, you always do tan. What's that called when it's not?
It's not always tan, it's whatever.
Yeah, it's the positive, but what's it called
Inverse.
again? Inverse?
Inverse. You can call it inverse or arc. Those are the two words we use for it. I don't use arc as often, but. So now we're going to talk about theta itself, okay? So let's talk about theta itself in this case. Theta itself in this case is a little bit different. So we started on our initial side, and to form the r, we had to go from here all the way to here. So regular theta spanned all the way across. It went from here all the way over here. But our goal is to find that value. So let's talk about it in this case. So theta went all the way for the first two quadrants and then some. Any ideas on how to find it?
180 plus the angle.
Good, 180 plus the angle. Very good. Which will come out to be 258.7 degrees. So like I said, you have to look at the picture and see what's happening to find theta. That's really the only sure way I can tell you how to do this, because every case is going to be a little bit different. Now, there's going to be a case for each quadrant that has a rule, but I think it's easier to just see it than to try to memorize all those rules. So is everybody good with how we found theta? 180 plus the angle.
Yeah, how'd you find 180?
What?
How did you find 180?
Oh, I just know that the first two quadrants make up 180, right? So we span the first two quadrants completely plus the theta prime. So we added all those three up. Yep. Is everybody ready to try another one? All right, next one. So we have C negative 4, 5. So negative 4 is over here, 5 is up here. We end up in the second quadrant. You take that point, you connect it to the origin to the best of your ability. And remember, we want that bow tie shape, meaning we're going to go down this way, and then we're going to go out this way. It gives us that bow tie shaped triangle. This is theta prime. This is your right angle. And now we can go ahead and label the sides. This is R. This is my horizontal distance, negative 4. And this is my vertical distance, 5. To find my R, I'm going to use Pythagorean theorem. 5 squared plus negative 4 squared is equal to R squared. That comes out to be 41.
Does it matter which way you do it?
You mean like if negative 4 was here and 5 was here? No. Yep, the two legs can be either position. The only thing that matters is the hypotenuse has to be on the other side of the equal sign alone. So this comes out to be R equals square root of 41. Okay. There's like a piece of hair in my mask. I was like breathing it. Okay, anyways. Sorry, my pen's acting up a little bit today. I don't know why.
I thought you were trying to draw the piece of hair that was in your mouth. Like,
Yes, that was my goal. I was trying to really describe it to y'all.
It's a diagram.
Yes, I need a diagram of that. I have to draw a whole mask and everything.
It's fun not the picture book.
Yes. So, now that we have that, we're going to do our trig functions. Sine is opposite over hypotenuse. Cosecant is just the reciprocal of that. Cosine is adjacent over hypotenuse. Secant is just the reciprocal. That's a 4. And tangent is opposite over adjacent. Cotan is adjacent over opposite. Now we will rationalize sine and cosine, like that. And now we can figure out which angle we need to use. Which one are we going to use here? Sine, because it's positive. Okay. Now, I don't know if any of you are wondering what happens if we used any of the other angles. It'd be the right answer, but it would be negative. So you could, and then just make it positive. But I just stick with the easiest way to do it. So 5 divided by 41 square root equals, and then second sine. That should give you 51.3. I'm sorry, what? Oh, how do we do it? Gotcha. So I use the pre-rationalized form. So 5 divided by 41 square root equals, and then second sine. 51
And that's defined, is it?
theta prime.
Theta prime.
Theta prime, not theta.
Is that how it'll always be? You'll always use
Always.
sine?
Not always sine, but the one that's positive. See how there's only one of these over here that's positive?
Okay, and it's always on the left. It's
Always the one on the
sine, cosine, and tan.
Yeah, because these ones don't have buttons on the calculator.
That's true.
So that's kind of another way to remember it.
Okay.
So here, we now need to find actual theta. So actual theta went here until it touches the terminal side. So it always goes from the initial side, which is your right side of your x coordinate plane, and it goes all the way to the terminal side. So this is regular theta. So any ideas on how we could find regular theta?
Wait, Miss Russell, how do you find that angle again? It's the
Theta prime, 5 divided by 41 square root equals second sine.
I'm sorry, could you write it out for me?
I don't really have a way to like write it out. I mean, you're just doing like 5, this is it right now. So 5 divided by
So 5 divided by
41 square root equals
equals
second sine. Yes, 51.3. If anybody's having issues with the calculator, I'm happy to help you. I'll just do it at the end, like, so then I can come around and like help you personally, because that'll be easier, and then we won't have to pause it. So how could we find regular theta itself? 180 minus, that would work good. So 90 wouldn't work because, let me explain why we would do this. So this comes out to be 128.7.
yeah, mine says error.
Yeah, you're probably just mistyping in something. It's okay. Well, I'll come and help you at the end. Because there's really no way for me to do it than just to show you. Alright. So, see how this theta prime and theta form a 180 degree angle together? So to find theta, we would just do 180 minus theta prime, which would give me the rest of the, basically they're supplementary. Okay? Does everybody see that? Alright, you ready to try a real world problem using this concept? Yeah. Okay. You swim across a 100-foot river. By the time you reach the other side, the current has carried you 25 feet downstream. What is the angle measurement formed from the starting point to the end point? So we draw it in our axes. Now the reason I'm only drawing like the main axis being the first quadrant, anybody know why I'm only really caring about the first quadrant here? Good, everything is positive. Good, everything is positive. Now here is my axes, and let's pretend like I'm just going to draw this like this is my river, just to give you an idea of like what this is looking like. Okay. So here's my river. Okay. And this is the width of the river, and the width of the river is how much? Good, 100 feet. Okay. The width of the river is 100 feet. And how far along the river did I go? I went 25 feet downstream. So here's me. I started over here. And if you're going up a river, if the river's flowing, you're not just going to go straight across on a river, right? You're actually going to kind of go like this, right? Diagonally. So you're going to go like this. And they're telling us that this distance right here is 25 feet. And I end up over here. This is my angle. We're just going to call it theta. Or you can call it theta prime. All right, you ready to do some calculations? All right. So, what trig function would we use to calculate this?
Sine.
Sine wouldn't help us too much because you don't have the... can't we just use tangent, opposite, and adjacent? Right? You could use you could find the other side using Pythagorean, but you don't have to. So it would be tan inverse of opposite over adjacent, right? And that's going to come out to be theta equals. So we do 25 divided by 100 is just 1/4, right? So second tan, that's going to give me 14 degrees. So this is part of the answer, but we have to be careful here. Because they said, what is the angle of measurement formed from your starting point to your end point? This is my start point. This is my end point. That's 14. But they didn't ask which angle. Isn't there another angle here too? This angle right here. Any ideas on how we could find that other angle? Good. So we can call this one theta, we'll call this one theta prime, we'll call this one theta equals 90 degrees minus 14 degrees, which gives me theta equals 76 degrees. So there's two measurements that have been created. The 14-degree angle, that's between the hypotenuse and the terminal side or the initial side. And then there's also the angle formed out here. So you have to be careful about these two, or these are the two answers here.
Russell,
Yeah.
This is kind of an off-topic question, but what day do we get off to school?
I think it's the 27th.
I am super excited to be.
Alright, now we're going to talk about quadrantal angles, okay? So go ahead and open back up to your... Quadrantal angles are angles in standard position whose terminal side resides on either an x or y axis. They are always multiples of 90 or pi over 2 radians. So basically they always fall on the axis, okay? And these fall neither in the first, second, or third or fourth quadrant because they fall directly on the line. So you can have them fall at 0 degrees, also known as 360. So just so you know, 0 degrees is the same thing as 360 degrees because it's a full rotation, right? Or 0 radians, and that will be r, comma 0. They can fall at 90 degrees, which is going to be 0, comma r. They can fall at 180, which is negative r, comma 0, or 270 down here at the bottom, which is 0, negative r. So let's talk about what that means. So if we have a unit circle here, now there is a little typo on your sheet. This should be a negative 1. Negative 1 on the bottom there, not a positive 1. So go ahead and fix that. Excuse me. Alright. Evaluate each trig function at the given quadrantal angle. So, before we get into this, let's talk about a few things that we know to be true. We know that tangent is equal to sine divided by cosine of whatever angle we're talking about. If tangent is equal to sine over cosine, what do you think cotangent is? Cosine over sine. We know that cosecant is the reciprocal of what? Sine. So 1 over sine. We know that secant is 1 over what? Cosine. And then we also lastly know that x and y correspond with cosine, comma sine. Okay? So sine is your y, cosine is your x. So these are some rules that are going to help you figure this out in a bit. So those are just some rules we talked about in previous lessons that are going to kind of come up and help you here. So I just want to kind of reiterate them. If you want to write them on the top, feel free to do that, or put them somewhere on your notes. It can be a little bit helpful. So evaluate each trig function at the given quadrantal angle. So sine of 0. So 0 degrees occurs right here, right? Everybody see that?
COT.
Cotangent. It's the reciprocal of tangent. So sine of 0 degrees, or 0 radians, same thing, that would occur here. So we have the points 1, 0. Okay, so which one's which? Anyone know? So, go ahead. So sine of 0, that's right here. So we look at the ordered pair right here. It's cosine comma sine, so sine of 0 is, it's 0, because this is cosine and this is sine. So sine of 0 is the y coordinate, which is 0.
How do you know which is what's the?
It's always cosine comma sine.
Okay.
Yep. Now we'll move on to cosine of pi. So pi is over here at 180 degrees. Cosine is the x-coordinate, so what's the answer? -1.
Do you always have like a circle like drawn?
You will actually this is from the unit circle, that big one that we filled in. So this is like a little piece of it. Now technically they wouldn't give you this, but you can always draw one and it always follows the same exact rules.
Miss Russell, what does that say next to cosecant? S what? C? I can't say because there's like a light block.
Oh.
SEC. CK.
Oh, SEC?
Yeah.
Yeah.
If it's like sine or cosine of 0, would it always be 0?
Like of 0? No, so cosine of 0 is actually 1. See at 0, this is 0 degrees. So that's right here. Cosine at that value is actually 1. See how it's 1 for the coordinate for cosine?
Oh, okay.
I'm using the ordered pair.
And then the reason why cosine pi is -1 is because cosine is for the x-value.
Correct. Does that make a little more sense now? Alright, next one is tan of pi over 2. That's 180. That's up here. So tangent is actually what divided by what?
1 divided by 0.
Good, 1 divided by 0. Because it's sine, which is the y, divided by the x. 1 divided by 0 is actually what?
0.
Oh.
Undefined. And I want to show you something about this. So pi over 2 is the same thing as 90 degrees, right? But in radians. So if you do 90 and hit the tan button on your calculator, you're going to get something that happens. Anyone know what would happen? 90 tan? Tan of 90 degrees? Error, because it doesn't exist. Cosecant of 3 pi over 2. So cosecant is 1 over whatever sine is, right? So what is sine of 3 pi over 2? -1. What's 1 divided by -1? -1. Secant of 2 pi. Now this one tricks people up. 0 degrees, it's the same thing as 2 pi, right? Because it's 360 and 0 are the same because they come all the way back around. If I'm at 0 degrees, 360 degrees is the same thing, okay? It's the same thing as 360 degrees. So we're looking right here. Now we know that secant is 1 over what? Cosine. What is cosine at 2 pi? 1. What's 1 divided by 1? 1. And cotangent is cosine over sine, okay? So, in this case, cosine over sine is going to be 0, because that's my x, over 1, which is what? 0.
It's not undefined.
No, 0 can be in the numerator, but not in the denominator. Does that kind of make it? It's a little tricky, but you kind of get the hang of it. As long as you use these rules up here. Alright, so let's try the next one. So it says the point at 0, 6 is located on the terminal side of theta in standard position as depicted. Find the exact values of the trigonometric functions of theta. So, basically this is your new ordered pair that we're working with. Instead of working with like 0, 1, we're now working with 0, 6. But nothing else has changed, okay? So, let's go ahead and figure this out. So, sine of this theta is what? It's the y-coordinate, which is 6. Cosine is just 0. Once you have sine and cosine, you can find any of the other ones, right? Because they're just versions of that, right? So tangent is what divided by what? Sine divided by cosine, which is 6 divided by 0, which is what? Undefined. Cosecant is 1 over what? Good. You're right, 1 over 6. Secant is 1 over...
Wait, you said cosecant is what?
Oh, sorry. Cosecant is 1 over sine. So it's just 1 over 6 in this case.
So anything with 0 is gonna be undefined.
Anything with 0 in the
Yeah.
denominator, yes. So secant will be 1 over cosine, which is 1 over 0, which is undefined. Hello? So then cotangent is cosine over sine, which is 0 over 6, which is just 0. Alright, how does everybody feel about that? Okay, we got one more page to do.
What?
What?
Oh, I thought we. For a second,
Oh,
like a whole
it's not a
different-
page for you, it's a page for me. But yeah, it's on the same page. So, if f of theta is equal to 6 sine of theta, evaluate f of 300. So, basically what we're doing is we're replacing our theta with 300. So, f of 300 degrees is equal to 6 times sine of 300 degrees. So I just replaced theta with 300. Now you can use the picture to draw this, but you don't have to. We've learned about this already. So we're basically just finding sine of 300, and we have to use a reference angle, right? So 300 falls in what quadrant? Good. Falls somewhere around here, 4th quadrant. 300 degrees. Okay. We should draw it on the inside. So we draw our this is 300 degrees. Okay. So we need to find our reference angle. So the rule for being in the 4th quadrant is to do 360 minus your angle, which is 60. Sine is what in this quadrant? Positive or negative? All students take courses. It's negative. So my answer here is going to be negative. Anybody remember what sine of 60 degrees is? It's okay, I'll just tell you. It's from your chart from 10-1. You have a chart, remember? Radical 3 over 2, but it's actually negative, isn't it? So that's just 6 times negative radical 3 over 2, which ends up being,
Why do you have A, S, T, and C?
so this is just stuff from older notes. This tells you what trig functions are positive or negative in the quadrants. So all of them are positive here. Only sine is positive in the 2nd. Only tangent is positive in the 3rd, and only cosine is positive in the 4th.
No, I get you.
So why are you doing the sine of 60 instead of the sine of 300?
So you always use the reference angle because we want what we call an exact value. If you did this in the calculator, it'd give you a decimal, which would be equivalent. But the rule is you take whatever this value is and you determine what quadrant it's in. And remember, you do the reference angle rule. So if it's in the 4th quadrant, you do 360 minus that angle and take the sine of that value. So this is kind of like a review. A lot of this notes is a review of other things. So the next one here we want to evaluate 5 pi over 4. I'm going to convert this to degrees. 225 degrees.
Is that when you multiply by 180 over 5?
Exactly. So this 225 falls somewhere about here. What quadrant does it fall in? Q3. So we're going to be taking tangent of, we want to do tan of 225. So we're going to have to use a reference angle. What's the rule for if you fall in the 3rd quadrant for a reference angle? Good. 225 minus, I should probably zoom in, huh? I can go back to the other one after if you want. This comes out to be 45. So we're going to be doing tan of 45 degrees, which is actually just 1. And is tangent positive or negative in this quadrant? Positive. So now we just have to take this amount and multiply it by what?
4.
1/2. And the answer is 1/2. So it's basically what you learned in 10.3, but just an extra step of multiplying it by something else. Alright. Is everyone good with that?
So you just draw the arrow in what quadrant instead?
How many degrees it makes up. Yep. You're opening that up how many degrees it is. Alright, and the last one we have today. The swing arms of an amusement park ride are 84 feet long. The axis height from which the arm swings is 97 feet. To the nearest foot, what is the height that the ride reaches in the depicted arc? So basically they want us to find this height right here. And they're telling us that this is negative 200 degrees. So if this is negative 200 degrees right here, what would this angle be here? 160, right? Okay, good. So, if this angle is 160, what would this angle be right here, this little one? 160 minus 180, or 180 minus 160, which is what? 20 degrees. So does everybody understand how I got the 20 degrees there? Okay, so that's 20 degrees. So now, if I look at this, I basically just have a triangle right here, right? I have a triangle with y, 84, and then this is 20 degrees. So does everybody see kind of where that triangle came from? It's right, this triangle right here. You see that? Okay, so how can we find y? We can use trigonometry, right? So this has an opposite and a hypotenuse. What trig function would we use to find that? Sine. Sine of 20 degrees is equal to opposite over hypotenuse. We put this over 1. We cross multiply. And we get y equals, and that would be 84 times sine of 20, which would be approximately 28.7 feet.
So y equals 84 times sine of 20?
Correct. So this distance right here is 28.7 feet. But that's not what the question asked for. The question asked how high this whole thing was. See that? They want to know this entire height. So how could I find that whole height right there?
Just add 28.7 and 97.
Subtraction.
Not subtraction, but addition. You're right, Bryce. So you're going to add them. So that comes out to be about 126 feet. So that's kind of how you would use trig on like an application problem.
Oh, you round.
Yeah, I just rounded it. You don't have to. That's fine. If you left it as 125.7, it's fine.
I was about to say, when you take off points, it's gonna
It depends on how I ask the question.